I'm Omprakash. I'm from BMS College of Engineering, first private engineering college in India. So today here I'm to present my project topic, which is titled as Optimizing Pavement Materials to Mitigate the Urban Noise Impact. This project is carried out by me and Nandish and under the guidance of Dr. Chetna R, Assistant Professor, Department of Civil Engineering, BMS College. As you all know, noise is a very unaddressed issue, and traffic generated noise is creating a lot of nuisance in metropolitan cities and all the cities all around. So it's very important to address the issue of noise generated by the traffic and the road surface. First, let's understand the definition of traffic noise. Traffic noise is an unwanted sound which is produced by vehicles, roads, engines, tires, and horns, which can disrupt the environment and health. And it's very important to address the issue of noise generated by the traffic and come up with the mitigation strategies and the solutions which help us to reduce the noise generated by the traffic and road. And talking about the pavement, pavement is a durable road surface, or we call it as a path where we walk. It can be made up of concrete as well as asphalt, and it is designed for the vehicle as well as pedestrian movement. And it is a very unaddressed issue, and a lot of research has been taken place on how to simulate and design the traffic and how to model the traffic in order to make sure that the signals are addressed. So considering that, in this particular research, two different types of pavements have been considered. One is flexible and one is the rigid pavement, which is also called as a concrete pavement. And the current focus in this particular study mainly deals with the surface noise level generated and not the subsequent layers which are shown in the second figure mentioned over there. The problem statement for this particular study is as follows. Urban noise pollution from traffic is an issue affecting the city livability and public health. And as you can see, in the first picture, there is dense graded pavement, and in the second picture, in the first there is the open graded surface. Dense graded pavement is generally making more noise in comparison with the open graded pavements as per the research that is being shown, where there is significant amount of noise absorption and transmission that is taking place through the open graded pavements. From the dense graded pavement generating a noise anywhere between the range of 73 to 78 decibels to 68 to 73 decibels, there is a significant amount of noise reduction. Through the air voids, the noise are getting transferred and dissipated. And there are a lot of factors like pavement unevenness, megastructure, macrostructure, microstructure, stiffness and porosity, as well as the thickness of the pavement that affects the noise generated on the traffic. And this particular study mainly deals with the tire pavement interaction generated noise, and the study was being carried out. As per this methodology, the flexible pavement was compared with conventional as well as unconventional pavements, and the rigid pavement was compared with the conventional and unconventional as well. In case of flexible, conventional was bituminous concrete grade 2, which was compared with the unconventional OGFC, which is open graded friction course, and the unconventional second one, stone matrix asphalt. So in order to study how the material is structurally strong and durable enough, the Marshall mix design test was being carried out, and also to analyze the air voids in the specimen, maximum theoretical density was used. In case of rigid pavement, considering the conventional concrete, that is PQC, pavement quality concrete, which was designed for M40 grade, which was considered as conventional, it was compared with the unconventional pervious concrete, which was designed for M10 grade. And the specimens were casted for the Marshall specimen. The specimens were cylindrical. In case of the rigid pavement, the specimens were cubical specimens. They were cured for 28 days under the water, and then compressive strength was carried out to check how stable they are. And acoustic evaluation was done, and noise measurement and analysis was done. Noise was captured for 30 minutes for all the specimens. 3 specimens of each were casted, and they were tested for noise transmission and absorption. In this particular picture, as you can see, in the left side, the noise is being generated, and the noise is similar to the tire pavement interaction noise, which I already said, which is 70 to 80 decibels. And the concrete specimen, which is a cubical specimen, is placed in the center, and the top, bottom, as well as the side of this particular setup are sealed so that the noise is not transmitted through the little space that is available. and the sound level meter is kept on the right end, where the noise is observed at every second, and that noise was averaged over 2 minutes interval to critically analyze how much noise is being transferred through the air voids. And they are set up in an acoustic panel setup, where there are acoustic panels which are triangulated and they are placed inside that. And this is for the concrete specimen, and this is for the Marshall cylindrical specimen, where a glass fiber material was set up and it was placed in the center, and it had the acoustic panels which is pasted on either side, and the hole was made and the concrete specimen was fit, and through the air voids how much noise transmission and absorption is being taken place is observed in this particular thing. And these are the result obtained. As you can see in the first picture, it is a conventional BC grade to concrete, bituminous concrete grade to surface, which is laid, which had air voids of 7% and optimum binder content of 5.13%. And there were 3 specimens which were casted. The first one was damped and the other 2 were undamped. Same thing was carried out for the unconventional OGFC as well as stone matrix asphalt. Through the results, we could observe that there is significant amount of noise transferring through the air voids that is taking place in case of OGFC as well as stone mastic asphalt, which clearly states that using these unconventional materials, there can be significant amount of noise absorption and transmission that could take place through the air voids, and we can have a noiseless pavement environment. Talking about the concrete specimens, the unconventional concrete, that is pervious concrete, was compared with the conventional PQC, which had PQC had less number of air voids, where the pervious concrete had 15% of air voids. So the noise transmission and absorption is taking place more in case of pervious concrete due to higher amount of air voids, and it can be said that they can be incorporated to reduce the noise, and they also have additional benefits like water infiltration, and it acts as a drainage layer, which is good enough. Talking about the conclusions, BC grade to under the damp condition reduce noise effectively, but increase when it is dry. OGFC allows more transmission due to its porous design, and SMA provides a stable noise control as compared to OGFC, and we can see that OGFC is better. PQC is dense, which reflects more noise, and it's not ideal for the quiet zones. So we can incorporate pervious concrete, which is good enough in noise absorption, and reducing noise to the pavement selection enhances societal sustainability, which increases the urban livability, and it can also help in maintaining good health of the people. And the future scope of work can be carried out at different ambient temperature, varying the specimen's temperature, how they can affect the noise transmission and absorption, that could be studied. And this study can also be further carried out on rubberized asphalt, that is PRMB and RMB, and recycled composites can be used for the analysis. And alternate acoustic materials apart from acoustic panels can be used for the noise transmission and absorption. And also an economic analysis and construction cost analysis could be carried out to evaluate the feasibility and financial implications. And these are some of the references. Thank you.
Any questions from the audience? I have one quick question. What about the impact of vehicle speed on the...
Yeah, ma'am. That can also be carried out as a future scope of work, where due to the speed, the noise levels vary. So they can be carried out in the future.
Any other questions?
I see whatever you are doing over here, but actual verification can come only when you actually perform the experiments.
Yes, sir.
What you are doing over here, you're putting a acoustic tube over here and you're putting concrete and you're seeing how much is the noise at the end of this.
Yes, sir.
Okay, it's as close to as whatever you're saying, but do you have any plans to kind of lay something like that road kind of thing? And
Yes, sir. They can be incorporated in the metro cities where the noise.
What I'm asking is, do you have any plans to lay these kind of roads, or put a setup where you can put a road and there you can test it, a patch of road, something like that?
We can implement that by telling to this BBMP and other things in Bangalore.
Right.
Yes,
So,
sir. In our college, we haven't made a practical setup.
so there is a center of excellence for road safety in IIT Madras. They are housed in next building. Actually, it is called NAC1. They
Yes,
are
sir.
housed there. You can go to them. They can probably help you in getting it done.
Surely, sir. I'll get in touch with them. Thank you so much.